Today's lesson is on perfect squares and square roots. It's Unit 2, Lesson 5. A perfect square is the product of a number multiplied by itself. For instance, 10 times 10 is equal to 10 to the second power, or 10 squared, which is equal to 100. Taking the square root of a number is the inverse of raising a number to the second power. To find the square root of a number is to figure out what number times itself will equal the perfect square you are taking the square root of. So for this example, we have the square root of 100. We have to think what number times itself gives us 100. We know that 10 times 10 equals 100. Therefore, the square root of 100 is equal to 10. Sometimes it really helps us to visualize perfect squares and square roots. So let's take a few minutes and watch a video from mashupmath.
Hey everyone, welcome back to this introductory lesson on square roots and perfect squares. So we are going to start off our discussion by looking at a rectangle, and this rectangle has a width of 4 units and a length of 8 units. Now we're going to envision this in terms of area. So that width of 4, think of that as 4 equal size units, and we'll split it up along the width. And then for the length, we have 8 equal size units, which we will split it up along the length. And now we have these squares that make up the inside, the area of that figure. Length times width, in this case 4 times 8, which we know is 32. So the area of this rectangle is 32 square units. So now let's look at what would happen if we cut this rectangle in half. So now instead of it being a 4 by 8 rectangle, it's a 4 by 4, which makes it a square since all the sides have the same length. The area of this square, 4 times 4, we know is equal to 16 square units. And this relationship allows us to say that 16 is a perfect square, and also that the square root of 16 is 4, since 4 squared equals 16. And we can think of this relationship every time we think about perfect squares. Now, for example, if we took this 4 by 4 square and cut each unit in half to make it 8 by 8, now if we counted up all those squares to find the area, or just multiplied 8 by 8, 8 squared, we would get a result of 64 square units. So 64 is also a perfect square, and the square root of 64 is 8, because 8 squared will equal 64. So now we can say that a perfect square is a number that can be made by multiplying a whole number by itself, by squaring any whole number. So now we can revisit the two perfect squares from earlier, and that was the 4 by 4 square and the 8 by 8 square. Now 4 times 4, if we think of this in terms of area, is 16, which is equal to 4 squared. And 8 times 8 is equal to 64, which we know is equal to 8 squared. Notice again that 4 and 8 are both whole numbers. Now if we take the square root of 16, our result is 4, and if we take the square root of 64, our result is 8. So the most important thing to take away from this lesson is that relationship between a perfect square and its square root. So now we're going to go ahead and visually explore some of the most common perfect squares and their relationship to their square root. So 1 squared is 1 times 1, which just equals 1. 2 squared is 2 times 2, which equals 4. 3 squared is 3 times 3, which equals 9. 4 squared, again, 4 times 4, which equals 16. Again, these are all perfect squares. 5 squared is 25. 6 squared, 6 times 6 equals 36. 7 squared is 7 times 7, which equals 49. 8 squared is 8 times 8, which equals 64. We actually looked at that one earlier. And 9 squared, 9 times 9 is equal to 81. And the square root for each one of these perfect squares is the value that you had to square to get it in the first place. So for example, the square root of 4 is equal to 2. The square root of 9 is equal to 3. The square root of 16 is equal to 4, and so on and so forth. And this is why raising a number to the second power, or the power of 2, is referred to as squaring the number.
Okay, so now let's go ahead and look at this multiplication table. If you notice, on the left side it goes 1 through 20, and across the top it goes 1 through 20. So these are all the perfect squares, all the way up to 20 squared, which is 400. And if you notice here, along this line, the diagonal, those are all your perfect squares. So I could say the square root of 9 is 3, and that's the length of the side here. And if you also notice, here is 3, here is 3, and if I were to color all these in, I would have exactly 9 square units. 3 times 3 is 9, or we can say 3 squared is 9. That is one example. You will get to memorize all of these perfect squares 1 through 20. Fill in on your note sheet as many as you can. If you get stuck, go ahead and refer to the multiplication table that's shown in the video. I will get you started. 1 squared is 1. 11 squared is 121. If you look over here under the square roots, you think 1 times itself is 1. So that would go underneath the square root because the square root of 1 is 1. And then I look over here and I think, what is 11 squared? 11 squared is 121. And if I put that under the square root sign, I can think to myself, well, the square root of 121 is equal to 11 because 11 times itself is 121. Now you go ahead and pause the video and fill in as many as you can. Okay, so now that you're done, let's see how you did. Here are all the answers. Check your answers and circle the ones that you didn't remember. And you're going to have to make yourself some flashcards so you can remember these numbers. It is required for you to know or to memorize all your perfect squares up to 20. And then you'll need to know how to take the square root of those perfect squares. So now let's look at non-perfect squares. We can think to ourselves, well, we have this square root of 45. And I have to think, what two whole numbers does the square root of 45 fall between? Well, I think to myself, well, I know what the square root of 36 is. It is 6. And I know what the square root of 49 is, which is 7. So I can say that the square root of 45 falls between 6 and 7. And when I write it like this, I'm saying that 6 is less than the square root of 45, which is less than 7. So that is saying that the square root of 45 falls between these two numbers. For the second example, I think of 145, the square root of 145. I do know there's a square root of 169 because I know 169 is a perfect square. And then I know 144 is a perfect square. So if I take the square root of 144 and I take the square root of 169, I will know the two whole numbers that the square root of 145 will fall between. It'll be 12 and 13. And I know it's 12 because 12 times 12 is 144, and the square root of 144 is 12. Go ahead and you try the next two examples. Okay, let's see how you did. Did you figure out that the square root of 30 falls between 5 and 6? Good for you. Now, how about the square root of 220? How did you do there? Well, we have to think the square root of 196, which is 14, and the square root of 225, which is 15. So now I know that these two are that the square root of 220 falls between the two whole numbers 14 and 15. To help you get better, you need to do some practice. So pause the video and go ahead and do some practice. Let's go ahead and check your answers. How did you do? If you missed quite a few, then I would suggest making yourself some note cards so you can study. You're required to know all the perfect squares from 1 to 400, and then you're going to have to also know how to do 6 squared, 10 squared, 15 squared without a calculator. So the more you practice, the better you'll be. Let's go ahead and apply these. We're going to apply perfect squares. We're going to solve each problem, making sure we answer the question that was asked. We may need to draw a picture. Mr. Nice's backyard is an area of 225 square feet. If he wants to enclose his backyard, how many feet of chain link fence will he need? Let's go ahead and start drawing a square. We know that this square, or his backyard, is 225 square feet. To figure out the lengths of the sides, we would take the square root of 225. The good news is it's a perfect square. So what is the square root of 225? Well, that is equal to 15. So I know the length of each side is 15. If Mr. Nice wants to put a chain link fence, he's going to have to do a chain link fence around each side of the yard. So that means we have 4 15s. We have 4 sides, and each side is worth 15. So I do 4 times 15, and that gives me 60 feet of fencing. So to answer the question, I would say he needs 60 feet of fencing. Let's look at the next question, and we're going to let you try. Mrs. Wong has 144 tiles that she is going to place on her square kitchen floor. How many tiles did Mrs. Wong run across each wall? If the tiles are $3.79 each, how much did Mrs. Wong spend on each tile? So pause the video, take a few minutes, draw a picture, and see if you can come up with the answer. Well, let's see if our solutions match. So Mrs. Wong has 144 tiles. So that's a key piece of information. We know her kitchen floor is square. So I'm going to draw a square. And I know it's 144 tiles inside. So if I want to know how many tiles are along each wall, I would have to know what the side lengths are. So if I know that the whole entire unit is 144, I know the square root of 144 is equal to 12. So I know each wall has 12 tiles running along it. So each wall has 12 tiles. That answers the first part, or the first question. Now I need to know if each tile is $3.79 each, how much did she spend on tile? I'm going to go ahead and erase this here so I have room to do my multiplication. So I have 144 tiles in all, and each of them is worth $3.79 each. So I do 379 times 144. I do 9 times 4 is 36, and then I carry the 3. 7 times 4 is 28 plus 3 is 31. Carry the 3. 4 times 3 is 12. 12 plus 3 is 15. Now I go on to the second row. I fill in a 0. 4 times 9 is 36. Then I carry the 3 again. 4 times 7 is 28 plus 3 is 31. Carry a 3. 4 times 3 is 12. 12 plus 3 is 15. Now I do the last row. So I've moved over 1, 2 to my third place. 1, 2. 1 times 9 is 9. 1 times 7 is 7. 1 times 3 is 3. Now I add it up. 6. 1 plus 6 is 7. 5 plus 1 plus 9 is 15. Carry the 1. 7 plus 5 is 12. 12 and 1 is 13, plus that 1 is 14. Carry 1. 3 plus 1 is 4, plus 1 more is 5. So I use 2 decimal places in my multiplication, so I'm going to put my decimal place 2 places over from the right. So I know the total that Mrs. Wong spent $545.76 on tile. And that concludes our video lesson. See you tomorrow.